Thank you. So there are three different ways in which we can record the speed of a moving object, although normally what we actually do is we measure the distance and we measure the time. For example, with this car here, I've got a piece of black card. Now the piece of black card is 10 centimetres long, and I've got a light gate here. The light gate has a beam of red light going through it from one side to the other, and it's connected via this data logger to my iPad. And what it's going to do is measure the time it takes for the piece of black card to pass through. So the faster it passes through, the faster the velocity will seem to be. So if I go this way, quite slowly, we get a value of speed of 0.056. That's not very fast. If I go this way, we've got a much faster speed because it was moving faster. The distance is 10 centimetres, the time is measured from this. The faster the object is moving, the faster the speed will work out to be. It's a way of measuring speed without having to handle human reaction time. So again, if you go quite slowly through the beam, you get a low speed. If you go quite quickly through the beam, you get a faster speed. That's a quite useful way of doing things, and it's often how we work out speeds where we've got a very short time. So for example, if you're looking at the speed of a flying bullet, you might have it travelling through light gates like this, and you just tell the computer how big the bullet is. There's a different kind of data logger that we can use as well, which is called a ranger. So the next one I'm going to show you is a ranger, and in order to do that, my iPad is going to get confused in a second, because what I'm going to do is I'm going to give it a ranger to work with, which is a different type of timing device. And what it does is, just like a bat, so just like a bat, there we go, just a minute. Just like a bat, what it's doing, and you might be able to hear it, is it's sending out a sound wave and reflecting. At the moment it's reflecting off the ceiling. So the ceiling is just over 2 meters away, but if I put my hand in the way, you can see that the distance has become a lot less. So, sorry, there's one. If I bring my hand in, there we go. Okay. Now, if it gets less than 200 millimeters or 20 centimeters, it can't cope. As it gradually goes back up, it can cope with the distance, but unfortunately it goes out of screen. But the closer it gets, the less time it will take for the sound to return. The further away it is, the more time it will take. As I say, looking at the ceiling, it's taking longer because it's got to go all the way and come back, and it's able to work out the distance. So we can use these, just like bats do, to work out how far away things are. And that's better than a light gate because it gives you the range. You can do these things from range. If you're trying to find out how far away an aeroplane is, you'd use something like this. But you don't use sound waves, you use radio waves, hence radar. Okay? So that's an alternative way of doing it. The third way that I'm going to show you this morning doesn't involve the data logger at all, but what it does involve is something called a ticker timer. Now, a ticker timer consists of two parts. Okay, I've got my trolley that I'm going to carry on using, but this time I'm going to attach a small piece of paper to the end of it. So I'm literally just going to take a piece of paper and I'm going to use a bit of sellotape to stick the paper to my trolley. Now, the second part of the ticker timer consists of this device here, which contains a hammer and a piece of carbon paper. Carbon paper is used for leaving imprints, dark spots on things. Now, there's a hammer here, and I'm going to connect the hammer to my power supply. The power supply runs at 50 hertz, just like all mains devices. So what it will do is it will knock down onto the piece of paper, 50 times a second, 50 hertz. Now, what that means, if the paper is stationary, is that I'll just get 50 dots on top of each other every second. But if the paper is moving, then those dots will be further apart. And the faster the paper is moving, the further apart those dots will be. So we have about 12 volts on this supply, so that's about that. And if I turn it on, you can hear the hammer. You can hear the hammer going down, and what it's doing is leaving an imprint on the piece of paper. But if the trolley is moving, those dots start to be separated. And I'll show you what they look like in just a second. There it's moving quite slowly. If I move it more quickly, the dots will be further apart. So, if we look back at this piece of paper, we can see the dots are almost on top of each other to begin with, and then gradually they're getting further and further apart. And that's because the trolley was then moving. The further the trolley is moving, the further apart the dots become, so the faster the object must be travelling, because each dot is a 50th of a second after the last one. So you can work out how far it's travelled in a 50th of a second, and you can then average that to find the speed. Okay? Thank you very much. You can stop recording.